I just mentioned that we'll give it till 5 after, so 2:05, and we'll start, Yerlan. We had about 70 registrants, so I'm hoping we'll have a good turnout, and we're also live streaming it on YouTube.
So we are on air.
And we also have our translator on for the simultaneous translation.
Not yet.
Okay, I'll write in. Just gotta. Can you double check with Sergey? Should be working now. I assume he's on for the event. Our translator. Yeah, he's on. I see him. Hey, Sergey, you're ready, right?
Really sorry about that. Yeah, good.
Okay.
Yeah, but I don't see the interpretation channels.
I see it.
Use. I don't have them.
Alashir, please triangulate with Sergey for the interpretation channels. I see them. Okay, so we're ready to begin.
Мы готовы начинать.
I hear you. You have to go into the channels, Sergey.
I don't have them.
Hi, Brandon.
Hi. One second. We're just waiting for the channels to be fixed. Sergey, I see the channels here, English and Russian. I see them physically, so you should be able to see them.
No, I don't have. I am not appointed as interpreter.
Alashir, please appoint him as interpreter, like we did last time. And then we're going to start. Sergey, what about now? Can you please check your interpretation channels?
Negative.
1 second, please. We will start in 1 or 2 minutes. We're just fixing the interpretation. There was a small problem with the online interpretation. Okay, thank you very much. So the interpretation is working now. So just a very short explanation. If you would like to have an interpretation in a language which you don't understand, which will be either in English or in Russian, you go to the interpretation menu and you select the language that you would like to hear the interpretation in. And it's important to not hear feedback to put mute original audio when you're listening to the interpretation. So with that, I would like to begin our conference, which is the Global Nature-Based Solutions to Mine Industry Water Waste from Research to Practice. We're quite excited that we had about 70 people register for the event. And we're also streaming this event live on YouTube. So hopefully we have at least another few dozen people watching on YouTube with the live stream. And before I introduce you to the great speakers that we have lined up today, from global companies like Tao Engineering Firm to international organizations like the United Nations Economic Commission for Europe, representatives from universities, and also from the government of Kazakhstan, I would like to take a short 30 seconds to remember the recent catastrophe which happened in the mining industry at ArcelorMittal in Karaganda, which was a few days ago, where we had the deaths of 46 workers. And we would like to take a minute of silence to remember them and to also reflect on the importance of mine safety and the relevance of this conference for today, and to honor those who passed away in this terrible accident. So 30 seconds, please. Okay, with that, I would like to start our event. We're very honored to introduce our opening speaker, which is Mr. Yerlan Shulanov, who is the provost for Narhos University, who will say a few opening words for us about the conference. Yerlan, the floor is yours.
Thank you, Brendan. Dear colleagues, dear the conference participants, thank you for giving me the opportunity to speak on behalf of the president of the university. Unfortunately, some apologizes. According to his schedule, he cannot participate himself. So, as the part of Narhos University commitment to sustainability, substantial investment has been made in this sector, including the Sustainable Campus redevelopment project completed last year. The investment in sustainability related to educational programs, as well as the creation of Sustainable Kazakhstan Research Institute, SKRI, led by Dr. Dupree, All this has led Narcos University being ranked according to the Times Higher Education Impact Ranking as one of the top 400 universities worldwide in the several Sustainable Development Goals, including goal number 10 on reduced inequalities and goal number 16, peace, justice, and strong institutions. All this aligns with the strategic priority of the university. We strive to produce leadership in business and to work with the private sector and governments to produce social impact. Innovation and applied research to solve real problems linked with the implementation of the SDG, Sustainable Development Goals, which plays a fundamental role in our objective. Therefore, the SKRI has been built up to be at the global forefront of innovative applied research project with the private sector and governmental institutions, including the development of low-cost nature-based solutions to protect, manage, and restore natural ecosystems impacted by industrial and urban waste, simultaneously benefiting people and nature. The work made by SKRI is in this sector has been presented internationally as a good practice within the scope of United Nations Economic Commission for Europe's Convention on Water and Industrial Accidents regular meetings. It has been also been covered widely in the international press, including journals like Forbes magazine, Yahoo Finance, and Market Watch. National institutions have also recognized our groundbreaking work on nature-based solutions to industrial waste through the appointment of Research Institute to Intergovernmental Working Group on Mine Tailing Safety under the Ministry of Emergency Situation and Industrial Accidents of the Republic of Kazakhstan and National ESG Club. One concrete example is their work on improvement of air quality in urban and industrial environments through a process created by Dr. Brandon Dupree and the team of experts called PhytoCapture. This approach uses various vegetation types such as trees and shrubs to disperse and also capture toxic dust, which is coming from industry and fossil fuel burning vehicles on the surface of vegetation. Using the advanced computer modeling, experts model plant surface atmosphere interactions concerning the outdoor environment with various pollution types such as dust. Using this model, they support city governments, business, and industry to examine the best location, design, and plant combination needed to reduce dust pollution, heat gases, and can scientifically illustrate the improvement of air quality through such design. To expand upon this portfolio, extensive research was conducted in 2 mining sites in Kazakhstan and Kyrgyzstan to develop conceptual design of the reduction of wastewater in mining operations. We are also in the process of negotiating a commercial contract to deploy one of these designs for heavy metal pollution in industrial waterways. Moreover, in 2022, we have received almost 650,000 euro in industrial contracts for the university as a whole alone. We also plan on some significantly expanding this sum in upcoming year. This will provide Narcos University with a competitive advantage in industrial research sector. During this event, we will hear not only from our experts, but also companies and governmental leaders from around the world. Please have a fruitful discussion. We are also sure that this nature-based solution project will upscale it, not only public and private sector of Kazakhstan, but also around the world. Thank you.
Thank you very much, Yerlan. That was very to the point and clear on our priority for innovation in the industrial sector at Narcos University. Now I'm very honored to introduce Representative Eric Kurumbayev, who is the head of the Department of State Supervision in the mining and metallurgical industry of the Industrial Safety Committee of the Ministry of Emergency Situations of the Republic of Kazakhstan. I know that your ministry and department is very busy given the current emergency situations that have been occurring in Kazakhstan in the mining sector. So I very much appreciate your time and look forward to your comments and words. Mr. Yerik, Mr. Kuimbaev, the floor is yours. Thank you for your participation in this event. We're very much honored for your presence.
Спасибо, Брэндон. Пользуясь случаем, хотелось бы еще раз высказать соболезнования семьям погибших и пострадавших. От своего имени, от имени коллег. Еще раз спасибо, Брэндон, за предоставленное слово. Добрый день, уважаемые коллеги. Благодарю за возможность представлять Министерство по чрезвычайным ситуациям Республики Казахстан на данной конференции. На сегодня Министерство по чрезвычайным ситуациям Республики Казахстан совместно с Европейской экономической комиссией ООН ведется работа по усовершенствованию управления хвостохранилищем согласно признанным международным нормам, в том числе Конвенции о трансграничном воздействии промышленных аварий. Очень приятно осознавать, что подобного рода вопросы интересуют не только госструктуры, но также и высшие учебные заведения и подобные исследовательские центры и организации, которые выступают со своими инициативами в виде различных научно-исследовательских проектов и технических решений. Непосредственно тема сегодняшнего мероприятия наиболее актуальна и напрямую связана с деятельностью межведомственной рабочей группой по безопасности хвостохранилищ и предотвращению аварийного загрязнения вод объектов Казахстана, согласно приказу министра о рабочей группе по безопасности хвостохранилищ и предотвращению аварийного загрязнения вод воды в Казахстане. Это от 21 января 2023 года номером 20. Актуальность данного вопроса также подтверждается тем, что на территории нашей республики расположено более 120 хвостохранилищ, многие из которых выведены из обращения, требуют закрытия или рекультивации. Следовательно, Министерство по чрезвычайным ситуациям Республики Казахстан полностью поддерживает подобные инициативы, как проекты природоориентированных решений для хвостохранилищ, которыми занимается университет НАХОС, лицей исследовательского института «Устойчивый Казахстан». Государственные структуры готовы к открытому диалогу и обмену опытом и знаниями, что было отмечено на первом заседании рабочей группы по безопасности хвостохранилищ и предотвращению аварийного загрязнения воды в Казахстане. Мы уже знакомы с директором исследовательского института «Устойчивый Казахстан» Брэндоном Дюпре, который представлял университет НАХОС на первом заседании рабочей группы по безопасности хвостохранилищ и предотвращению аварийного загрязнения воды в Казахстане, а также на субрегиональном семинаре по безопасности хвостохранилищ и предотвращению аварийного загрязнения вод в Центральной Азии, который был проведен в текущем году в столице Республики Таджикистан. Следовательно, мы от лица министерства хотели бы оставаться в близком контакте, дабы отслеживать дальнейший ход работы и результаты подобных проектов непосредственно на промышленных предприятиях республики. Поскольку очень важно в подобной работе иметь широкий арсенал решений, так как промышленность в Казахстане развита и представлена различными видами отраслей, каждая из которых имеет свои определенные особенности, а следовательно и специфики, связанные с хвостовым хозяйством и производством. Также стоит понимать, что образовательный сектор играет важную роль не только в подготовке необходимых и высококвалифицированных кадров, но и для инновационных методов по решению актуальных задач, которые стоят перед государством в различных отраслях. Тем более в области промышленной безопасности, которая требует постоянного изучения и обновления практических и теоретических баз. Но что более отрадно, так это то, что научная общественность также обеспокоена вопросами безопасности хвостохранилищ и освещает подобные темы, также пытается найти альтернативные способы решения данных задач. В заключение хотелось бы выразить глубокую уверенность, что реализация намеченных задач на данном направлении позволит значительно снизить риск возникновения аварийных ситуаций на хвостохранилищах как следствие загрязнения вод. Также позвольте еще раз искренне поблагодарить университет НАХОС за приглашение поучаствовать в сегодняшней конференции. Благодарю за внимание.
Thank you so much, Mr. Kurumbayev. I think it's rare to see such interest and desire to work with the academic community by the ministry. So I very much appreciate your kind words and your willingness to cooperate with us. And we look forward to continuing our cooperation in the nearest future. And please send my sincere regards to Mr. Medike Pushimbayev as well, the Vice Minister of Industrial Emergencies and Industrial Situations. I very much appreciate his support and the support of the ministry. And thank you so much for your words. And I wish you all the best in your very important and urgent work that you have ahead of you. Thank you for sharing your time with us. And with that, I would like to give the floor to another excellent expert that we have. I would like to present Ms. Claudia Kamke. She's the Environmental Affairs Officer of the UNEC Convention on the Transboundary Effects of Industrial Accidents. And we very much appreciate her time. She's has such a large portfolio of work, 56 countries they're working in. So to participate in our event, we're very much humbled, and thank you. We look forward to your presentation. The floor is yours.
Thank you very much, Brendan. Thank you for the invitation. I'm happy to be here, and I'm about to share my presentation. So maybe you can confirm that you see it correctly and that you don't see any notes.
Yes, we see the full screen. Thank you very much.
Okay, super. Thank you very much. So thanks for the opportunity to speak. I would like to present UNECE's work and also perspectives on strengthening mine tailing safety and governance. And I will also refer to that, of course, in that also to nature-based solutions. So maybe a quick recap. It has been mentioned by Eric already, but the UNECE Industrial Accidents Convention has been adopted by parties in 1992, and it entered into force in 2000, and it currently has 42 parties. And in Central Asia, it also has, well, to date, the only party is Kazakhstan. However, Tajikistan is currently considering accession, and of course, we also hope that other countries will follow. Under the convention, numerous guidance materials and tools have been developed over the years on strengthening mine tailing safety. The convention itself is a legal instrument addressing that, but also there are the UNEC safety guidelines and good practices for tailings management facilities to support the practical application of the safety guidelines. A few years later, a TMF safety methodology has been developed under the auspices of the convention. Parties adopted a decision on strengthening mine tailing safety in 2020 under the convention. In addition, in 2022, a roadmap for action on tailings has been endorsed, and also, among others, an online toolkit and training on tailings has been developed. So the practical application of all the rich knowledge and guidance and tools under the convention has resulted in the development of inventories and maps of more than 1,000 tailings management facilities in the UNECE region. Several on-site trainings at tailings management facilities have been implemented to build capacity and improve the understanding of risks. And in Central Asia also, several interinstitutional working groups on tailing safety and the prevention of accidental water pollution have been created. Kazakhstan mentioned this earlier. There's also such a group in Tajikistan, and soon hopefully in Uzbekistan. and sub-regional and transboundary cooperation on this subject matter has been strengthened. So to dive a little bit into Central Asia, I just quickly want to tell you that in Central Asia, inventories and maps of 237 tailings management facilities have been developed. And you can see here, for example, in Kazakhstan, there are 121 TMFs, and basically in other countries, and also in the Sudaya River Basin, numerous have been mapped. From these 237 TMFs, 59 TMFs may have potential transboundary effects according to the criteria under the convention. And this makes 25% out of the tailings management facilities mapped in Central Asia, which is really a huge amount. Under the convention, over the years, I mentioned this before, capacity building activities have been implemented to improve the understanding of risks. So I don't want to go into details, but basically there was an on-site training at a tailings management facility in Kazakhstan in 2019 and one in Tajikistan in 2021, which were conducted basically also with participation from other Central Asian countries, and resulted also in the development of reports that contain the concrete results of the application of the UNECE safety guidelines and the related TMF methodologies. There are also recommendations for operators and competent authorities to improve tailing safety. We hope that at the end of this year or beginning of next year, a similar training will take place in Uzbekistan. The work under the convention has also strengthened tailings governance in Central Asia through the establishment of interinstitutional working groups on tailing safety and the prevention of accidental water pollution. I mentioned this before. Kazakhstan already held 2 meetings. The second meeting took place on 15th of March this year, and several actions also for follow-up have been agreed. Tajikistan held its second meeting on 4th of April this year, and Uzbekistan is still in the process of formally establishing these interinstitutional working groups. The formal establishment in Kazakhstan has happened through a decree of the Ministry of Emergency Situations in January 2022, and in Tajikistan this was done through a decision by the government of Tajikistan. The work also under the convention facilitated sub-regional cooperation. Mr. Kurumbayev already mentioned this. There was a sub-regional workshop in May this year. There were more than 70 participants, both online and in person, from all 5 Central Asian countries, including from authorities, operators, academia, NGO, and also regional and international organizations. The workshop also featured a high-level session which was attended by the Vice Minister of Emergency Situation of Kazakhstan, the Vice Minister of Natural Resources of Kazakhstan, the Deputy Minister of Energy and Water Resources of Tajikistan, and the Deputy Minister of Emergency Situations of Uzbekistan. The workshop really was rich in terms of recommendations and conclusions and needs, and I just presented here a few key needs and recommendations for follow-up. Which of course countries still need to work on, and we're happy to support them in. Kazakhstan, for example, suggested establishing a joint working group at the technical level on the monitoring and control of transboundary tailings management facilities in Central Asia. Tajikistan had a similar idea, but suggested that it should rather be a coordination council at the political level between Central Asian countries to explore the potential risks of TMFs and also prevent accidental water pollution. Uzbekistan pointed out the need to develop joint contingency plans, notably in river basins, basins in Central Asia. And several Central Asian countries also recommended to develop a joint contingency plan specifically for the Sudaya River Basin. The IWAC, the International Water Assessment Center, proposed launching a pilot project on assessing the impacts of climate change on tailings management facilities in Central Asia specifically to study the impacts and adaptation measures. And CSDRR, the Center for Emergency Situations and Disaster Risk Reduction, highlighted the need to establish a sustainable early warning and alert system at the national and regional levels to help countries prepare for hazardous climate-related events. So the vital role of the interinstitutional working groups as multi-stakeholder platforms for the exchange and coordination on mine tailing safety was also stressed by all participants, and it was recommended that other Central Asian countries also establish such groups in their countries. So you may wonder, how does this all link with nature-based solutions for tailings management facilities? The UNECE Industrial Accidents Convention basically works strongly on the prevention of industrial and also tailings accidents, on the preparedness and response to such accidents. And there are several possibilities to integrate nature-based solutions. For example, as regards risk mitigation and reduction measures, nature-based solutions can reduce the risk of industrial and tailings accidents. There are synergies with regard to hazard management and water quality control. And so nature-based solutions can help control surface water, soil contamination, and so on, and also as such mitigate the effects on water quality and water pollution, and this also across borders. So not just within a country, but also across borders. There are linkages with regard to environmental protection and remediation and disaster resilience. So nature-based solutions can restore the ecosystems and minimize the environmental damage. Also there are strong linkages with regard to knowledge exchange and international collaboration. So the knowledge that is gained and the practical application of the nature-based solutions can be shared, for example, at meetings or of the Conference of the Parties, or also at respective seminars or workshops under the convention. So overall, I think nature-based solutions can serve as a valuable tool to mitigate risks, protect people and the environment, to enhance disaster resilience, and also engage communities for tailings management facilities. However, I don't want to leave without saying that there are also challenges and limitations of nature-based solutions. But of course, I think you're aware of that. So I just put on the screen a few important considerations. So of course, nature-based solutions need site-specific adaptability. There needs to be long-term monitoring and adaptive management for continued success. And of course, there are integration challenges. It requires the cooperation among different stakeholders and regulatory bodies for the successful application and implementation. And of course, there can also be challenges in terms of the potential land use. So there could be competing land uses in mining areas during the installation. It needs technical expertise to implement nature-based solutions. Also, there could be potential financial constraints for investing into this. And of course, there may be resistance to change or lack of awareness. So and also there are challenges can be related to the transport and disposal or processing of contaminated plants and or filter systems. But I'm sure you will cover this a bit more in detail as we go through the seminar. I just for a more balanced representation, I also wanted to mention a few possible challenges. However, that being said, we believe this is an interesting and an important tool to help protect people in the environment from the negative and adverse effects of industrial accidents and tailings accidents specifically. And as such, it also helps to implement the 2030 roadmap for action to strengthen mine tailings safety. This is a roadmap that was endorsed by the parties to the convention in 2022. It contains 5 key objectives, which I put on the slide. So, for example, to improve the understanding of TMF-related risks, to address TMF risks through policy and governance, to prevent and prepare for accidental water pollution, to prevent NATEC accidents, so natural hazard-triggered industrial accidents, and adapt to climate change, and also to exchange information and knowledge and capacity building. So under each of these objectives, parties agreed to take very specific actions, and of course, nature-based solutions can also help parties implementing this. And how specifically, I don't want to spend a lot of time on this, but basically parties agreed to implement certain actions in this biennium 2023-24 and in the next biennium 2025-26, and among others this will help improve a shared understanding and risk management of tailings management facilities within and across countries, and this will also facilitate multi-stakeholder dialogue in this regard. So before finishing my presentation, I would like to draw attention to a few upcoming events that may be of interest to you. As I mentioned before, an on-site training at a tailings management facility in Uzbekistan is planned at the end of this or early next year. Then there will be the interinstitutional working group meetings in Kazakhstan, Tajikistan, and Uzbekistan next year, probably in the first half of the year. There is a JAC workshop on the prevention of accidental water pollution from tailings management facilities planned in Slovakia in April next year. This will be held with Russian interpretation, and both in-person and online participation will be possible. So you're invited to join that. And last but not least, I'd like to draw attention to the 13th meeting of the Conference of the Parties to the convention, which will be held in November, December next year, and which will, among others, also include a roundtable discussion on tailings and feature also a discussion or an exchange of knowledge on INSAR technologies for tailings specifically. So with regard to that, I would like to close my presentation and show you a video on mine tailings safety, which features a bit more or shows a bit more the work that UNECE has been done and the tools that are available for all member states within and beyond the UNECE region. And that having said that, Brandon, can I give back to you and you play the video?
Yeah, Alishir, our colleague from SKRI, will play it. Alishir, please play the video.
Okay, so I stop sharing.
I would need the sound as well. I don't hear it.
Yeah, I also don't hear the sound.
Строительство дорог, производство
Yeah,
It's working
very
now.
good.
Горнодобывающая промышленность имеет важнейшее значение для социально-экономического развития и промышленности. Добытые полезные ископаемые используются для строительства дорог, производства электромобилей и современного электронного оборудования. Но добыча полезных ископаемых также приводит к образованию большого количества опасных отходов, которые часто хранятся в специальных сооружениях, таких как хвостовые дамбы или пруды. С 1970 года объем добычи металлов и других полезных ископаемых вырос в 3 раза. По мере перехода к низкоуглеродной экономике потребность в них увеличится еще сильнее, а вместе с ней и количество отходов. При неправильных проектировании или эксплуатации хвостохранилище представляет большую опасность для людей, окружающей среды и инфраструктуры. В случае аварии на них могут образовываться грязевые волны, подобные селевым потокам, разрушающие все на своем пути. Катастрофа, вызванная прорывом дамбы в Брумадиньо в Бразилии в январе 2019 года, потрясла мир. Поток привел к разрушениям на протяжении 8 километров, погибло 259 человек. Сооружение и эксплуатация хвостохранилищ без учета последствий изменения климата, таких как сильные дожди или снегопады, также опасны и могут приводить к значительным материальным потерям, как показал прорыв плотины в Баия-Маре в Румынии. Авария вызвала сильное трансграничное загрязнение воды в Венгрии и других странах, расположенных ниже по течению, а также в Черном море. Это всего лишь 2 из многочисленных аварий, произошедших в прошлом, и статистика показывает, что их последствия становятся все более серьезными. Предотвращение аварий на хвостохранилищах, в том числе их трансграничных последствий, и обеспечение безопасности должны стать приоритетными задачами. Нельзя и дальше вести дела как прежде. В странах с переходной экономикой возникают дополнительные проблемы, связанные с бесхозными или заброшенными хвостохранилищами. Это часто бомбы замедленного действия, поскольку вопрос не в том, произойдет ли на них авария, а в том, когда она произойдет, если ничего не предпринять. Правила и стандарты безопасности в этих странах могут быть устаревшими и должны быть приведены в соответствие с современной международной практикой, например, с руководящими принципами и надлежащей практикой обеспечения эксплуатационной безопасности хвостохранилищ, разработанными Европейской экономической комиссией Организации Объединенных Наций, ЕЭК ООН. Руководство содержит принципы обеспечения безопасности и рекомендации для правительств, компетентных органов и операторов, занимающихся эксплуатацией хвостохранилищ. С целью оказать содействие странам в практическом применении руководства ЕЭК ООН по безопасности хвостохранилищ, Германское агентство по окружающей среде разработало для органов власти и операторов методику на основе контрольных списков. Прежде всего, компетентные органы могут классифицировать свои объекты в соответствии с индексом опасности хвостохранилищ. Для этого им нужны только основные данные, такие как объем отходов, токсичность хранимых веществ и параметры безопасности дамб. Индекс опасности хвостохранилищ помогает определить перечень объектов, требующих срочного внимания. Затем операторы могут использовать контрольные списки для выявления основных проблем в области безопасности и управления на отдельных предприятиях. Это помогает им определить необходимые краткосрочные, среднесрочные и долгосрочные меры и оценить потребности в ресурсах. Методика также включает каталог мер, которые можно использовать. Руководство по безопасности хвостохранилищ и методика на основе контрольных списков успешно применяются горнодобывающими операторами и службами обеспечения промышленной безопасности во всем регионе ЕЭК ООН для повышения безопасности хвостохранилищ и совершенствования их эксплуатации. Для успешного управления хвостохранилищами особое значение имеет межведомственная координация и трансграничное сотрудничество, поскольку аварии часто имеют трансграничное воздействие. Для обеспечения безопасности власти должны координировать работу на национальном, региональном и местном уровнях, а также с операторами и другими заинтересованными сторонами. Органы власти и операторы работают сообща, невзирая на границы, не только для предотвращения аварий, но и для защиты здоровья людей и окружающей среды. В дополнение к улучшению ситуации на местном и региональном уровнях, совершенствование эксплуатации хвостохранилищ способствует выполнению повестки дня в области устойчивого развития на период до 2030 года, включая Сендайскую рамочную программу по снижению риска бедствий и цели в области устойчивого развития. Эта работа также содействует улучшению управления в горнодобывающей промышленности и повышению устойчивости инфраструктуры. Применяя эти принципы, органы власти и операторы, эксплуатирующие хвостохранилища в регионе и за его пределами, будут готовы предотвратить аварии на объектах хвостохранилищ. Это важно для того, чтобы полностью исключить аварии и ущерб, который они могут нанести.
Thank you very much. That was a very interesting presentation, and interesting that you mentioned sea spray from tailings, because one of the designs that was developed by our team was to combat issue linked with sea spray from tailings. So I think later you'll find out more about that, and I think it may be of interest to you. Thank you very much for your presentation.
Thank you.
So I will now be presenting, taking my hat off as moderator, and now presenting as the director of the Sustainable Kazakhstan Research Institute. And my presentation will be more of the general concept of nature-based solutions. And my colleagues will speak more specifically about the work we did together in this specific project. 1 second. Is my screen clear, visible for everybody?
Yes.
Okay. So as I mentioned, my name's Brendan Dupree. I'm the founding director of the Sustainable Kazakhstan Research Institute, which was founded 4 years ago in 2019. And we work specifically on bridging the gap between traditional academic research and practice. So our institute is solution driven, and we work on practical projects to try to support the implementation of the Sustainable Development Goals here in Kazakhstan and worldwide. And we work on a host of different types of projects and programs. But one particular component which has gained traction has been our work on nature-based solutions to mine tailing waste, but also of urban waste as well. And I'd like to just give you a short definition of what nature-based solutions are. They're solutions that are meant to protect, manage, and restore natural ecosystems impacted by human activity, and in this case, industrial waste, simultaneously benefiting people and nature. And what I would like to say is that the World Bank in 2021 published a report where they mentioned the need for solid empirical research and scientific research on how nature-based solutions can be applied practically to solve issues linked with unsustainable practices. And so my institute has been working with that topic deeply for the past 4 years. We've gained a lot of attention for this internationally. So our work was presented as a good practice within the scope of the regular UNECE Convention on Mine Tailing Safety and Industrial Accidents meetings. We were also participating in the event, this interministerial working group on mine tailing safety. We presented in May in Dushanbe. And also we have received commercial contracts with various companies to deploy these nature-based solutions. One in particular that we completed was our work with Altinalmas company. And this year we signed a commercial contract with RG Gold to work on the deployment of a phytocapture barrier at their mining operations to reduce the mine tailing dust and to improve the overall health of the mine workers who live and work on site and are affected by the mine tailing dust. Our work has also been covered widely in the international press, including Forbes magazine, Yahoo Finance News, and Market Watch. We're also on the interinstitutional working group on mine tailing safety for the Republic of Kazakhstan under the Ministry of Industrial Accidents and Mine Tailing Safety. So what I would like to do now is to present one particular concept or methodology that we developed to help reduce airborne dust pollution from mine tailing sites. So Alashir, I'll stop sharing my screen and I ask you to play the short video on that.
Just a second.
Okay. Big screen. Yeah.
Have you ever been to a construction site and seen dust flying around in the air? Have you ever wondered what is that cloud you see in urban cities during peak traffic hours? What you see is fine particulate matter called PM, which is tiny particles of organic chemicals, acids, metals, and dust emitted from fossil fuel burning vehicles and factories, construction and mine tailing sites. These particles can easily penetrate the human respiratory system, causing lung and cardiovascular diseases or exacerbating respiratory illnesses. By one estimate, 8.9 million deaths a year globally could be attributed to exposure to outdoor fine particulate matter. This problem exists not only in urban cities, but also in industrial sites like mine tailing sites. To tackle this pressing problem, the Sustainable Kazakhstan Research Institute has developed an innovative nature-based solution to deal with airborne dust and to help support the implementation of the Sustainable Development Goals through innovative nature-based solutions. The technical solution is called phytocapture. This approach uses various vegetation types, such as trees and shrubs, to disperse and also capture particulate matter on the surface of this vegetation. Using advanced computer modeling, our international experts model plant surface atmosphere interactions concerning the outdoor environment with various types of pollution such as PM. Using the model, we support industry and local governments to examine the best location, design, and plant combination of the vegetated barrier that can be used to reduce particulate pollution and scientifically illustrate the improvement of air quality that will occur with such designs. Our research team has proven such a barrier can reduce PM from source pollution by over 35% and other emissions by over 70%, providing a direct and positive impact on human health. The Sustainable Kazakhstan Research Institute can not only model these designs, but also has an international team of experienced experts that can help support the technical process of planting the barrier. Our research team is at the service of industry, city governments, and other stakeholders around the world to provide world-class services to those in need. The SKRI, providing technical solutions to some of the world's most pressing sustainability challenges.
Okay, thank you.
Brandon, the floor
Yeah,
is yours.
I'm sharing the screen. Okay, so why is this useful for the mining industry? Because how do mine companies typically deal with dust suppression? They have Bowser systems or spray systems that they spray on either the roadways or adjacent to the mine tailings. And they're usually chemical sprays that have chlorides inside. And they need to do it either annually or biannually. So it's costly for the company. Each time you spray, it's about $10,000 to $20,000 per 1.5 kilometers for doing the spray. On top of that, you have to do it regularly, so it's not a long-term solution. And these chlorides also are not good for waterways because the chlorides can leach from the road surfaces and go into the neighboring waterways and is actually quite toxic for the aquatic life that live in these waterways. And so phytocapture actually helps companies because they also it helps them comply with regulatory requirements. And in particular, in other countries, it's similar, but just to talk about these specific requirements in Kazakhstan, is that they have the environmental codex on subsoil users, and they're required to finance research, scientific and technical, or development work in the amount of 1% of the total production costs. So essentially 1% of the production costs have to go into academic research. So they're required to do it by law, and they're required to spend that money. Secondly, you have sanitary zone protection requirements, which say that up to 40% of the total territory of a mine needs to be covered by different types of vegetation. And those two specific requirements are two specific budget lines for the company. One budget line is the sanitary zone protection requirements, and the other budget line is their research requirements. And so they can conduct research with phytocapture to find the best design for a phytocapture barrier that will capture and maximize the capture of dust. And they can also use that research to then also plant the vegetation that's required under the sanitary zone protection requirements. So they can use the budget for research to do the planting of the vegetation. So actually, it saves the company money, specifically in Kazakhstan. So as I mentioned, we did this. Here you can kind of see what it looks like in the modeling. We have the different particles modeled, and then how the vegetative barrier interacts with those particles. You can see how the tree is digitalized online, and then the parameters of the tree, leaves, and vegetation are also put into the computer model. And so what I would like to do now is to quickly share just 2 minutes of a video, 2 short minutes of it, which is the promotion for ESG that was conducted nationally for Altin Elmas company on the project we did with them at their mining site. Alashir, please play the video. More further. Just 3 minutes. Okay, a little bit back.
Решение систем обыкновенных дифференциальных уравнений, который позволил изучить рассеивание аэрозольных частиц, а также пассивных и реактивных газов. 1400 саженцев деревьев и кустарников, такие как вяз, серебристый лох и клен, были высажены на расстоянии 1,5 километров. Эти виды растений были выбраны не зря. Серебристый лох, который имеет высоту около 1,5 метров, эффективен для удержания крупной пыли, а клен и вяз, благодаря росту более 3 метров и обилию листвы, помогают при удержании мелкогабаритной пыли, которая поднимается при ветре. Выбранные растения будут эффективны и в санитарном отношении, и достаточно устойчивы к загрязнению воздуха и почвы промышленными выбросами. Компьютерное моделирование показало, что чем ближе деревья к источнику пыли, тем выше эффективность фитозахвата. Именно поэтому расстояние между хвостохранилищем и посадкой 10 метров, а расстояние между деревьями и кустарниками варьируется от 1 до 2,5 метров. Таким образом, загрязнение воздуха будет снижено до 40%.
Okay, that's good. So you get the idea and how that can be useful for mine companies. So what are the benefits on top of what I mentioned? It's low cost. It's a long-term solution. It aligns with national legislation. It reduces air pollution and subsequently water pollution, and provides scientific evidence needed for the site beautification projects. So they plan on planting vegetation in any case. And so they can have a scientific methodology to plant that vegetation to try to maximize human health impacts. And finally, it's good for ESG and consumer outreach. Not to go into detail, we've expanded upon our portfolio, and we also had a project which will be talked about in more detail with our colleagues to work on nature-based solutions to water waste specifically. And so we spent a year working on that project, and then now this is the close of the project, and we'll learn about the results of the project with our colleagues and speakers from Tao Foundation. But what I would like to say, which is also very important, is that we're happy to announce that we're in the process of contracting a commercial contract to implement a reactive mat for bioabsorption of heavy metals in wastewater for a company in Kazakhstan, which is under a non-disclosure agreement with us. But we're happy to announce that that commercial contract should be concluded by the end of this year, and should be the implementation should begin in January. Also, this is good for companies' ability to fulfill their requirements for ESG. So what companies usually are required to do, they're supposed to identify their material resources, analyze their business model, define KPIs, and then report on their progress. And here are some of the KPIs that can be key performance indicators that can be developed by the company for such projects. So for example, from an environmental perspective, KPI, you can have the total dust reduction rate, right? That can be one of the KPIs for the phytocapture project. From the social component, you can have a KPI related to the health impact of dust on neighboring communities near the mining operations. And for the water waste work, you can measure on the environmental key performance indicator, you can measure the quantitative reduction of the physiochemical indicators of water quality. And on the social perspective, you can have performance indicators on the quality of drinking water on site. And so these types of projects can be integrated into the entire chain of ESG performance for the company, and can provide real results in terms of improving a company's performance in relation to ESG, and also subsequently, of course, improving human health. So thank you very much. We will be leaving questions and answers for the end of the, unless you have a pressing question, Claudia, now, or can you wait until the end of the event?
I can wait until the end of the event.
Okay, all right. Thank you very much for your time. And then now I will take my hat off as the presenter and go back to my moderator role. And I have the distinct pleasure of giving the floor virtually and in recorded format to our dear colleague, Paul Bardos, who's the director of R3 Environmental Technology, Ltd. It's a very big company based out of Great Britain. And he works on all sorts of projects linked with this topic all around the world. I think currently he's in China, but he did record a presentation for us so we can learn more about the work that he does. So I ask Alishir to please play his presentation, and I am presenting him in virtual format. Thank you.
Hello everybody, my name is Paul Bardos. I'm the director of a small environmental company in the UK and a professor at a local university here. I would like to talk to you today about sustainability and nature-based solutions and give you an illustrative case study from the Czech Republic. And I'd like to thank the conference organisers very much for their kind invitation to speak to you. I'll turn the camera off because I don't think it was doing very much good in any case. I'd like to give some acknowledgements for this talk. The presentation is based on two things. A new book that I've written, which was coming out next year, which was supported by the FECO office of the Ministry of Environment and Ecology in China, and a European Life Plus demonstration project called Life Papua, which is using combined in situ treatment in engineered wetlands to deal with lindane polluted water. In this talk, I will give you a very brief introduction to risk management, to sustainable and risk-based land management, low input remediation, including nature-based solutions, and then I'll go to the case study at Hayek in the Czech Republic. Well, I guess you're all very familiar with risk assessment, but just to make sure we're all on the same page, I'll start from the top. What creates a risk? Well, a risk is a connection between a source of the hazard and a receptor, which is something that could be affected by it, like human health. For that connection to exist, there needs to be a pathway between the two of them. So these three elements together give rise to a risk. Looking at these three elements also shows us how we can manage risks, to mitigate them, to reduce them to acceptable levels. We can treat at the level of the source, which we call source management. We could treat contaminants as they migrate along the pathway, which we call pathway management. Or we could intervene at the level of a receptor. For example, an institutional control like restriction on use of water from a well. In practice, risk management usually combines several interventions at the same time at the level of the source, the pathway, and the receptor. Now, until the mid-2000s, it was generally assumed that if you did remediation, it was de facto sustainable because you were removing the contamination. However, we now realize that the treatment of the contamination may not be sustainable. For example, if you remove contamination from one site to put it in a landfill, maybe you're just transferring the problem to a future generation. So the idea now is to combine risk management and sustainable development so that the project provides a net benefit to sustainability overall. So sustainable and risk-based land management has two key components: the mitigation of unacceptable risks from contaminants, which has to take place, and to maximize sustainability gains and minimize sustainability losses from that process. So the optimum remediation solution needs a balanced decision-making process that mitigates these unacceptable risks and maximizes overall net benefit. And this can take place either across a portfolio of sites, within a specific site at the planning stage, or after the planning stage when you're looking at the remediation of specific source pathway receptor linkages. When we're looking at sustainability gains and losses, these are usually highly site-specific and highly project-specific. So you can't make general rules about them. On the other hand, it can be useful to identify if there's a family of technologies which might tend to have lower sustainability impacts. And this family we call low input remediation. So the four main features that we're looking at here
We're looking at remediation which uses fewer resources to get the same risk management result, which uses less energy to get the same risk management result, which might be able to use a greater amount of renewable inputs, for example, renewable resources like biochar or renewable energy like photovoltaic, and also, and particularly importantly, remediations that have wider benefits. For example, they improve the wider functionality of the soil as well as dealing with the contamination that's in the soil. So this idea of low input remediation is strongly connected to concepts like nature-based solutions or gentle remediation options. Some examples might be in situ stabilization using renewable biochar or phyto-based techniques, plant-based remediation techniques, monitored natural attenuation, and natural source zone depletion. So now we come to the case study, the Hayek site in the Czech Republic. As I'm sure you know, until the late 1980s, the Czech Republic was a communist country that was occupied by Russia. So this site at Hayek, the pollution in this site came during this communist period. It's a former uranium mining area where lindane production wastes were also dumped. And lindane is a pesticide which has a very large level of production wastes because only one isomer of the HCH compound is actually usable as a pesticide. So the uranium mining took place from the 1960s to 1971. And between 1966 and 1968, the authorities decided to dispose of 3,000 to 5,000 tons of pesticide production residues in metal drums in the quarry, slag heap. In 1977, a landslide occurred and part of the stored chemical waste was exposed. The landslide was stabilized using crushed aggregate, which had a drainage system with some pipe drains. Since the fall of communism, the levels of contaminants that are in that drain have been monitored. In the picture, you can see the drain that's coming from the landfill, and that drains out to surface water and causes significant contamination. And there's also contamination from the water into the surrounding soil around that channel. So between 1999 and 2002, the site owner commissioned some initial remediation work to put a cover and capping layer over the disposal area. However, the drainage from the site remains polluted. In 2015, a remediation option appraisal was carried out and concluded in favour of an in situ treatment and engineered wetland. And these are the low input remediations that are of interest to us. The system that has been developed by this LifeBot project is called Wetland Plus, and it has 4 main components which all use cheap, readily available, reusable materials. So there's sedimentation in sand to start with, iron filters using microscale iron, which provides chemical reduction of some of the contaminants, and then the bioabsorption unit, which uses naturally occurring sorbent materials, and finally a polishing treatment, which is an aerobic wetland system. Here you can see some pictures of the installation of the in situ treatment parts of the Wetland Plus system. You can see the scale of it. This was built about 3 years ago. And And this is what it looked like last July. The top picture is looking out towards the in-situ treatment units, and the bottom picture is looking out towards the engineered wetland. The person you can see in the white shirt is the project coordinator, Professor Miroslav Cernik, and the other person is the Thailand ambassador to the Czech Republic, who came there on a visit. The next segment goes to the sustainability assessment. This was quite a detailed activity, and it was carried out in compliance with the International Standards Organization standard on sustainable remediation. Many different people were participants in this process, so it is quite a robust sustainability assessment. The assessment itself was qualitative based on rankings. So number 1 was the best ranking, that was a gold medal winner. Number 2, number 3, number 4. Well, actually only 3, because we only had 3 technologies we were comparing. What we did was we looked at the Wetland Plus system. We benchmarked it against what would have happened if we'd used a conventional chemical wastewater treatment plant, that's the one in red, or if we'd made no change, which is the one in blue. So the smaller the area, the better. We compared about 70 different criteria, which are grouped into 15 headlines, 5 for each element of sustainability, 5 for environmental, 5 for economic, and 5 for social. If you would like to find out more information about this, please take a look at the website for the project, and also at the SURF UK website, which is at www.claire.co.uk/SURF UK, SURF UK. So you can see that on all points in our sustainability assessment, the Wetland Plus outperformed the other 2 hypothetical options. Lower emissions to air and lower impact on water, lower impact on ecology, and lower use of natural resources and lower generation of waste. There's only one point where they all tied, which was at the impact on soil and ground conditions. That's the wider impact on its functionality. So if we come to the economic element of sustainability, again, Wetland Plus outperformed conventional chemical wastewater treatment plant or no intervention on just about all points. Now, I can't spend a lot of time on this because I'm running out of time in my presentation. Looking at the social aspects, both treatment interventions were broadly similar, with each had their own pros and cons, but both were better than no intervention. So my conclusions are, firstly, that low input remediation is definitely worth considering for contaminated sites in Kazakhstan, particularly large sites. They are lower maintenance and lower cost as well. Sustainability assessment is a very useful tool for both option appraisal and for validation of what you've done to show that you've achieved the sustainability gains you were hoping for. And I'd like to offer you, although it's not Christmas yet, an early New Year's resolution suggestion. You're very welcome to come read my book. So just as a final advert, this is the structure of the book. It's from the beginning to the end of sustainable and risk-based land management, from site investigation all the way through to carrying out the remediation. It's about 250 pages. There's about 1,000 citations in it. I hope it's quite a clear narrative. It's not being published yet. It will be published in 2024. Email me if you'd like more information. It will also be being published in Chinese by the Chinese government.
Well, I'd like to say, thank you to Paul for his presentation, although he's not here. But it was very, very interesting, especially the concept of how to assess the impacts of these nature-based solution interventions. And so I think such a sustainability assessment tool that Paul spoke about would be very, very relevant for the work that we're doing. Moreover, looking at the scale and size of the intervention that they did, really, it's was quite impressive. So we appreciate his presentation. Now, moving forward, I would like to present Guido van der Korlet. He is our partner at Tau, but he wasn't able to make it today. So we're lucky to have Ellen Verboom, who is the project engineer for Tau Engineering Firm, who will be presenting on Guido's behalf. And her presentation will be on promoting, or could you mute your microphone, please? Thank you. So her presentation will be on international innovations with nature-based solutions, global examples. Ellen, yield the floor to you.
Thank you very much. I'm in a separate office, so I hope the background noise isn't too bad. Otherwise, I'll move somewhere else. Let me just share my presentation.
It's a bit loud, the background noise.
I'll see if I can move across the hall. Sorry. Something there. Apologies for that. I am sharing my screen now, right?
Yes, but we see the other slides. It's not full screen. Okay, it's full screen now. Thank you very much.
Okay, perfect. So thank you, everybody. My name is Ellen Verboom. I will be giving a short presentation on some of the nature-based solutions that we have developed at Tau BV. I will first introduce myself and my organization, then go over some of the nature-based solutions that we have designed, and finally go over how these solutions could be implemented in Central Asia. So my name is Ellen Verboom. I work as a project engineer for the International Environmental Projects at Tau. I have a bachelor in natural environmental sciences and a master in biology and chemistry of soil and water. And my work at Tau mainly focuses on site investigations and remediation designs for contaminated sites, and then with a special focus on nature-based solutions. So Tau is a European environmental consultancy firm. We currently have offices in 6 different European countries and have 1,200 employees. We were founded in the Netherlands in 1928, so we celebrated our 95th birthday this year. And we actually started as a consultancy firm, technical consultancy firm for the Union of Water Boards. So our core business really is water. And in the 1960s, we expanded, added additional services to our portfolio, for example, soil, circular economy, nature restoration, health and safety. And we expanded throughout Europe. And in the 1980s, we became a leading company in contaminated site assessment. TOW is an employee-owned company, so we all have assets in the firm. And as I mentioned, we have a lot of experience in situ and ex situ remediation of contaminated sites. We started off with more conventional remediation techniques, but in the last years, we've also included nature-based solutions into our portfolio. And these are some more traditional nature-based solutions, such as phytoremediation, but we also aim to design some more innovative nature-based solutions. The picture here on the right, I will go a little bit more into detail on this side later in the presentation, is a large dump site in the Netherlands of both municipal solid waste and chemical waste, and we transformed it in a natural area. One of our success stories with regards to nature-based solutions. And I have prepared 4 examples of nature-based solutions that we designed. The first one is a reactive mat for biosorption. The location that we designed this for was a polluted canal in Ghent in Belgium, next to an old asphalt factory. Because of the asphalt factory, the groundwater at this location was heavily polluted with aliphatic and aromatic hydrocarbons. And at the location of the canal, there was upwelling of this groundwater, so this contamination would rise to the surface. We designed a reactive mat with biochar and peat, so the water that came upwelling flew through this reactive mat. And the biochar and peat offers binding sites for these pollutants, thereby filtering out the contamination. And this was a very big success. There was a reduction in pollutants from 85 to 100%. At some point, these mats become saturated with the pollution, so they have to be replaced. And for this specific case, that would have to be every 10 years. So the lifetime is quite long. And we're also looking into options to recycle these mats, so the materials don't have to be produced again. This is a picture of the implementation. So as you see here on the most left picture, it's a mat with different compartments with the organic compound that does the filtering, so either the peat or the biochar. And then the outside compartments are filled with sand to ensure that the whole construction stays in place. They were simply put in the bottom of the canal, and the water would flow upwards through it and filter out all the contaminants. Then a second nature-based solution is an iron oxide coated sand filter. This location is a large lake, the Spiegelglas in the Netherlands, which was heavily contaminated with phosphorus from agricultural soils. This is a very common problem in the Netherlands because we have such intensive agriculture, and this leads to eutrophication of the lakes, which leads to extensive algae bloom, which basically kills anything else that lives in the lakes. As you can see here in the picture, there was a large agricultural field with different waterways that flow into the lake here at the right bottom corner. And we built a iron oxide coated sand filter in the final part of the water flow. Iron oxide coated sand filter is a waste material from the deferrization of drinking water. So we also added a bit of circularity to this nature-based solution, because normally this project is just being dumped in waste dumps. And the phosphorus binds to this sand filter. And in this project, again, very successful, this led to a 93% removal of the phosphorus load. And this is what the filter looks like. The water flows in on the left side flows through the filter and then flows out again on the right side. So it's a very easy methodology. There are two options for the water flow. You can either have a downflow where the water flows in on the top side and just naturally flows down due to gravity and then flows out on the other side. Or you can have an upflow where you pump the water on the bottom side and pump it up through the filter and then it exits on the top side. The benefit of the downflow is that it doesn't require any energy, which is required for the upflow. But it does require a bit more maintenance because any particulate matter that is present in the water can precipitate on the filter and might block it. So every once in a while you would have to clean it out. Then another nature-based solution that we used are tree wells. This was for a small location on the Dow Benelux site in the Netherlands, in Terneuzen. And Dow is a very big chemical company, production of chemicals. And they had an issue with BTEX contamination in their groundwater, which is what the project focused on. And there was also additional contamination of chlorinated hydrocarbons at that location. We used tree wells to both contain the contamination with a geohydrological barrier, but it's also used for phytostabilization and phytoextraction. So the pollutants are being bound in the root system so that they can't migrate anymore. And through uptake of the pollutants, they are actually being removed from the groundwater. For this project, we used poplars, eucalyptus tree, and willows because they have a very high water uptake, which is required for this type of nature-based solution. This current project is finished now. They have cut down the trees and they're building a factory, another factory at this specific area. But because of the big success, a new project is being implemented at the north side of the Dow Benelux site, so over. Oh, my mouse has disappeared over here, where there's a PFAS contamination. So where we are going to see how that works for a different type of contamination as well. Now, how do tree wells work? I have a picture here on the left. You plant a tree with their root system in a root sleeve, which is impermeable. And you place a straw that goes from the tree sleeve into the groundwater, to the contaminated area. Now, the only way that the tree can retrieve water is to suck it up through the straw. So if you would have a groundwater stream, if you have contamination on the left side and your water streams from left to right, all the contaminated water gets sucked into the straw and therefore is prevented to spread to other areas. And then within this root sleeve, there's a lot of physical chemical processes that take place, which also immobilize and extract the pollutants from the water. And this is what it looks like. In practice, this was when the trees were just planted. As I said, by now they have already been removed, but the containment and the removal of the contamination was very successful. And then the final nature-based solution that I would like to discuss is the Volgermeer landfill site in Amsterdam, which I showed in one of the previous photos. This was a 100-hectare large landfill, which was dumped in a former lake. These were chemical wastes mixed with municipal solid waste. And this was a big problem because of the infiltration of rainwater was polluting the surrounding areas. So the actions that we took for this area was that we removed the target waste and we placed a peat layer above the dump site as well as a waterproof cover. The peat acts as a natural barrier It was also placed around the dump site, so any contaminated water that would flow over or out of the dump site was filtered with this peat layer. And in addition to that, there was a regeneration of a natural area. It's a very popular recreational area now where people go to hike and bike. So that's an additional benefit of this project. And we have a monitoring network to assess if the contamination is indeed being kept in place, which is the case. So another success story. Now, some of these nature-based solutions that I've just presented can also be applied in Central Asia with regards to mine tailing remediation, possibly with a few adaptations, but the overall principle would work. So the reactive method I've mentioned can be efficient in the treatment of acid mine drainage. Biochar and peat are very effective adsorbents for heavy metals because they have a negative surface charge. So any heavy metals that are present in the acid mine drainage will be filtered out. And in addition, biochar can neutralize acidity, so thereby also treating the acid mine drainage itself. The iron oxide coated sand filter that we use for the removal of phosphorus can also be used for the removal of heavy metals through fixation. There's already several studies that have shown great success with the removal of several heavy metals from industrial wastewater and stormwater runoff. And then finally, the tree wells could also be used for groundwater treatment in both rural and urban areas, both with phytocontainment, but also with phytostabilization and phytoextraction. I think we're saving the questions until the end of the session. I see Brandon nodding. So then I would like to finish my presentation. Thank you for your attention. And I'll give the floor back to Brandon.
Thank you very much, Ellen. That was very interesting. And what we like in my institute is a lot of really practical solutions to some of these problems. So I look forward to asking you a few questions at the end of our event during the question and answer session. So now I would again like to introduce Ellen and also Tobias, who I believe is still on the call. And they will be presenting the results of our field research as part of the MBS joint work with Narcos University. And within that context, we developed 3 prototype designs of nature-based solutions to mine tailing water waste. And so they will be doing a joint presentation together where they will be sharing the results. I'd also like to introduce Tobias Prastra, apologies if I didn't pronounce your last name right, who is a consultant for soil, groundwater, and sustainability for Tau Engineering firm. But he has huge experience in the water sector. And so we're very happy to have him as part of our team and to have worked on this project together, and also for him to share some of the results of our project. We're quite proud of the outcomes we've had together. So thank you, and I give the floor to both of you to share the interesting results.
Thank you, Brandon. I'll share my screen again. Presentation. Okay, thank you. Then for my next presentation, we will look into the results of a field research for nature-based solutions to mine tailings presented by Tobias and myself. I will first introduce ourselves, or mainly Tobias, because I've already introduced myself. Go over the project description, go over some general nature-based solutions that can be used for mine tailings. For this project, we visited 2 sites, one in Kazakhstan and one in Kyrgyzstan. We will go over the site issues that we have identified and the preliminary nature-based solutions that we have designed for these sites. And then over the follow-up actions and conclusions that we can draw from these site investigations. So Brendan already briefly introduced Tobias. Tobias and I both work at Touw BV engineering company. Tobias is a senior consultant for soil, groundwater, and sustainability with a bachelor in environmental sciences and a master's in environmental hygiene and soil quality. He has 27 years experience as an environmental consultant and engineer, and he is the nature-based solution expert within Touw. Then the project description. About 2 years ago, we started a project for remediation of nature-based with nature-based solutions between Touw and Naxos University. This project is funded by the Touw Foundation, and it focuses on the prevention, remediation, and restoration of mine tailings environmental impacts with the use of nature-based solutions. And this specific project focuses on pollution by leachate from the mine tailings and process water basins. There were a few potential pollutants that we focused on, which were acid mine drainage, which occurs due to the oxidation of pyrites, heavy metal contamination, anions, and some additives that are used within the processes of the mining, such as cyanide. There were 5 different phases of the project. We did a literature research on the best global practices for nature-based solutions of tailing contaminations. We developed a publication of mine tailings that are suitable for nature-based solutions in Central Asia. Then we did a site visit for data collection on 2 selected sites, and we designed a nature-based solution for these selected sites. And the final phase, this session is part of this phase, is the international stakeholder consultation on the results and potential to actually realize these pre-designs of the nature-based solutions. So we visited 2 pilot sites for this project, one operating gold mine in Kazakhstan, and one uranium and metal mine in Kyrgyzstan, which has been closed for about 50 years. And we focused on the source pathway receptor subjects to identify where there are risks, as Paul Bardos explained during his presentation. We had a fieldwork mission at the end of April to visit those 2 sites and do some soil and surface water sampling to develop a conceptual site model and eventually also a preliminary design for the nature-based solutions for the issues that we have identified. We tested the concentrations of pollutants in the soil and water, and we compared those results with the maximum values that are allowed in the Dutch legislation. Dutch legislation is the internationally most widely accepted form of legislation in terms of soil and water contamination. And it was more elaborate than the local legislation for the sites that we visited. So I will first go over some general issues and solutions that are used for nature-based solutions in mine tailings. So one of the most prominent problems is the formation of acid mine drainage, which happens when sulfide minerals in the soil are oxidated, which forms sulfuric acid, which is then dissoluted, which leads to an decrease of the pH and increases the sulfate concentration in water. This is a natural process which happens naturally in the soil, but because in mine tailings the soil is less compacted, there is increased exposure to oxygen, water, and microorganisms, which really increases this reaction. And this is why there is such a steep decrease in pH. And then a consequence of this acid mine drainage is the mobilization of heavy metals. So under a neutral pH, most heavy metals are sorbed to solid soil particles, and they are not mobile and they are not bioavailable. But once these protons are being released into the environment, so the acidity, these protons compete with heavy metals for the binding site on soil particles. So they become mobilized. There's a higher bioavailability, and they can also be transported to other areas. And then there's also some site-specific impacts that depend on the type of mining that occurs. For example, if there's mining of uranium, you might have radionuclides present in the water. Chemical additives might be used, such as cyanide for the mining of gold. And anions such as sulfate, nitrates, and phosphorus might be released into the environment. Of course, there's already some solutions to these problems. The first one is liming, which increases the pH. And an added benefit of this is that heavy metals that have been mobilized by the increase of acidity will also be immobilized when you apply liming. You can use both inorganic and organic compounds for this. They both have their benefits. Inorganic is usually more efficient. However, organic compounds also improve other soil qualities. So often there's a combination of the two that's being used. And there's also a number of waste products that can be used. For example, the marble industry has a lot of marble dust, which is quite high in pH. So this is very easy to apply to these mining sites. Then another option is the heavy metal filters, which I sort of explained in my previous presentation. Organic matter is negatively charged and therefore offers binding sites to heavy metals, which are positively charged. So applying an organic matter filter will bind these heavy metals to the organic matter and leave you with clean water. An added benefit of this is that most or some organic materials, such as biochar, are slightly alkaline, so they also increase the pH, battling the acid mine drainage simultaneously. And then the final option is phytoremediation. For mine-related pollution issues, there are mostly two types of phytoremediation that are applicable, which is phytostabilization, which immobilizes the pollutants in the soil. So either plants release certain compounds into the soil that precipitate pollutants, or the pollutants can adsorb to the root system, thereby decreasing their mobility and bioavailability. Or phytoextraction, which is uptake of the pollutants from the soil into the plant tissue. You can permanently remove these pollutants by harvesting the plants. The plants take up the pollutants by their roots and then translocate it to their above ground biomass. Okay. Then I will give the floor to Tobias. He will tell you a bit more about the two sites that we visited, the work that we did, the problems that we found, and the preliminary nature-based solutions that we have designed. The floor to you.
Thank you, Ellen. So we visited two sites, one in Kazakhstan and one in Kyrgyzstan. We did that with a team of the Naxos University, TAU, and local support staff at the end of April this year. And as you can see, we were quite lucky with the weather because this was just after a really cold period. Next slide, please. So what we did in Kazakhstan at the site was taking 5 soil samples or sediment samples and taking 5 water samples, in this case surface water samples, as well as that we tested the surface water with a sort of test kit on base of indication strips. So a test on anions and cations. We have the analytical results. We sent the samples to the laboratory, and we got the results back. In this case, in the soil, we didn't find any soil contamination. All tested heavy metals were below the Dutch intervention values. But for the surface water, we saw some indications of pollution, at least increased above the Dutch legislative values for surface water. And this goes for some heavy metals like chromium, copper, zinc, of which especially copper increased the legislative value with 20 to 240 times this threshold. At the same time, we saw sulfate in the surface water at about 8.5 times the legislative value, and cyanide at about 6 times the legislative value. Next slide, please. So what we did next was identifying these issues by the model that Paul Bardos showed us. So the source, the pathway, and the receptor. And we identified 3 issues. First, the one I showed you in the earlier sheets with regard to the contaminated surface water, of course. This was measured in a creek that came out into a large river. So, and the river flows further, and so there is some migration. So the surface water is a pathway or a source, how you see the start. And then you can imagine that this river also might infect wildlife or livestock that uses the surface water, and eventually the people that live in the vicinity of the river or near the site, and the mine workers themselves. Another issue we identified was the sea spray. I thought we were unique in identifying this issue, but I heard Claudia was talking about the sea spray, so I'm really glad she already identified this issue. In this case, there was a processed water basin, a really large one, and in this landscape there is a really harsh wind, so you can imagine that there are waves in this basin, and because of these wave breaks, there will these will produce sea spray. So small droplets with contamination in it. And the last issue we identified are the dust clouds that Brandon already talked about. These were already included in previous project of Naxos University. But this is an issue, I think, that is valid for all sites, for all the mining sites. Next slide, please. So we focused on two of these issues. One is the heavy metals in the surface water. As Ellen already showed, we already have experience with adsorbing contaminants with certain green adsorbents, like peat and other adsorption materials of natural origin. These heavy metals are positively charged, and organic matter is negatively charged, so they attract to each other, and then the heavy metals are adsorbed to for example, the biochar. for this site, we need to do additional fieldwork to demonstrate, first of all, the structural presence of these contaminants, because we only did one measurement in the time. So we're not sure if this is a structural problem or issue. And after that, we would like to be able to design the final filter system, also on base of the data we collect in the field. And in the picture below, you see how that could work. So you see the green lines which picture the natural filters that are put in place in the surface water before it enters the large river. Next slide, please. Yeah, the other issue we identified here was the sea spray from the tailing facility or the pond. We know that the complete capture of the sea spray is not realistic, but we thought, okay, what can we do? What could be solutions? One of them is the addition of calcium-rich materials to increase the pH, if that is the problem. And if you do that, and if it's an acid pond, then these pollutants will precipitate. So they won't be migrated by the sea spray. Another option could be the growing and harvesting of resistant algae, which incorporates these pollutions into their tissue, and then these algae can be removed and destroyed. And the last option we saw is that we could implement constructed wetlands at the edges of this tailing storage facility to capture the large sea spray droplets. You can, for example, imagine that you implement reed beds at the downwind side of this large basin. And that's a bit the same option as Brendan showed for dust. Next slide. So we could go to the second site, Kyrgyzstan, which is a closed uranium and rare metal mine. We did this a few days after our first visit in Kazakhstan. The weather was nice as well, as you can see on these pictures. What we did here was to take five surface water samples and some soil samples and some sediment samples. Next slide. So the analytical results here. It's the other way around at the Kazakh site. In this case, we saw in the soil the contamination. So some increased levels above the Dutch intervention value for arsenic, lead, and zinc. For lead, this was 7 times the intervention value. And locally, we saw some increased levels of some rare metals like yttrium and zirconium. In the surface water, the contamination was less, and only slightly increased concentrations were found of arsenic, sulfate, and ammonium. Of course, in this case, because it was a uranium mine, we had to find out if our samples were radioactive or not. So we had local support, and there was no radiation in our samples, fortunately. So we could transport these samples safely at home in the Netherlands. Next slide. Yeah, also here we looked at the issues, of course, and the source and the path and the receptors. Here we have the heavy metals contaminated soil, some sulfate in the contaminated water, surface water. And in this case, we also knew by the local support staff that the isolation constructions that were in place here had a certain lifetime. As Alan already told, this site was shut down more than 50 years ago. So you can imagine that isolation constructions have a life already of 50 or more years. So this is an issue, but this is a construction issue that we didn't look further to. Next slide. In this case, for the contamination of the soil, one of the options is to implement plants or trees. So to phyto-extract the contamination or phyto-stabilize the contamination at the roots. Phyto-extraction takes place in the root tissue. So then you have to take care of the leaves and the other parts of the trees and the plants. Additional research, of course, is needed for selection of the plant species. It has to be a local species that can resist the local climate, because it's quite a harsh climate. So it has to be a feasible solution. That's why we preferably have native plant species. Next slide, please. Yeah, about the follow-up and the conclusions with regards to these sites. The conclusion is, of course, that we found contaminants in the pathway from source to receptor, and we think that nature-based solutions can provide a solution to the issues that were identified at the two sites. And as I said, additional actions are needed for a final design. As Claudia of the UNEC already said, there are, of course, limitations to nature-based solutions. Some of them are predictable, some of them are not. So you have to do feasibility studies, first on the desk study, then a lab study, and then on a pilot scale. Then you can say, okay, this is a feasible solution. So these two sites for us are pilot sites, and we hope these sites will bring us a sort of blueprint for the other mine tailing sites. It's good to mention that a follow-up of the project at the Kazakh site has been initiated. So we are trying to do additional measurements there at the surface water, see what the flux is of the surface water, see what the spatial dimensions are, get insight into the fluctuations of the concentrations of the contaminants. And then phase 2 is, on base of these site investigation data, to calculate, to do calculations on the dimensions of the construction, and to do laboratory studies for that as well, such as batch tests. And then we can make a more detailed remediation design and implement it. So these are the steps we have to take. So the phase 1 is the detailed design, the detailed site investigation. Phase 2 is the detailed remediation design. Then we go into the field again to install the installation. In this case, the adsorption installation to adsorb, in first instance, heavy metals, but we are also looking at the sulfate and the cyanide to see if we can do anything about them as well, if necessary. Then, of course, we have to operate this construction and to monitor it, to find out about how it works and if it does the job. So the higher goal of this all is to assess and demonstrate nature-based solutions for applications at other mine tailing sites with pollutant migration risks. And this is where I end my presentation. And I'm really curious about questions of the audience, of course. But I give the floor back to you, Brandon.
Thank you very much. And that was a very interesting presentation. And one thing I maybe would like to add, so I'm taking my moderator hat off again, and as somebody who was part of these field assessments, is that this wasn't by design, it was by opportunity in some ways, that we managed to go to 2 different sites. And you may have mentioned this, but I could have missed it. But that one of the sites was an abandoned tailing, So there was still ownership of that by the shareholders, but it wasn't actively being developed. And the other one is an active mine. So in terms of the research team, there's a whole compendium of different types of situations and scenarios that apply based on whether it's an abandoned tailing or it's an actively operated site. So that was quite interesting for our research team, and actually posed a lot of challenges in terms of what type of solutions we were proposing to offer based on that. So I'm sure there'll be a lot of questions. I have some questions for you as well at the end. But now I would like to introduce our next speaker, Dr. Dora Almasi. She's also a longtime colleague who's been working for a very long time on nature-based solutions. And she actually is the research lead for the Urban Nature Atlas, which is a global database for urban nature-based solutions, collecting these best practice examples from all over the world. And she will give us some of her expertise, presenting some of the best practices that she's uncovered in her research, and tell us more about the global nature-based solutions urban atlas. Thank you, Dora, the floor is yours.
Thank you so much, Brendan, for having me. It's a pleasure to be here. I would like to welcome everybody. Good afternoon. So as Brendan mentioned, I'm going to talk about the Urban Nature Atlas, which is a global database of urban nature-based solutions. I will share my screen. Can you see it? Can you please confirm? Super. So the Urban Nature Atlas is a product of an EU project, which was called Naturevation. It's a Horizon 2020 research program of the European Union that started to fund nature-based solution research projects back in 2016. So this is when we started to work on this project. This is the most comprehensive database of urban nature-based solutions. The cases are collected as a result of a systematic survey based on secondary resources, and we present them online at the una.city website. So today I'm going to talk about the main findings that we have about nature-based solutions around the world. What are the implementation characteristics, how they are being managed, and I will try to make a special outlook on wastewater management challenges that we have identified through the Atlas. The Atlas started with the collection of 1,000 cases from Europe, but slowly throughout the years, we have extended this with cases outside of Europe. So now we have also cases from Asia, Africa, and South America in the Atlas, almost 250 examples. So we can now firmly say that this is a global database, and we have knowledge about what is happening around the world. This is how the Atlas looks. I'm encouraging you to visit it. We had the chance last year to work with Brendan and his team, and we already added the project that Brendan and his team were working on last year about the phytocapture. So we hope we have the chance to add the new good practice soon from Kazakhstan. So basically, the Atlas is enabling viewers to search, not only to visit good practices, but also to search for them based on the type of nature-based solutions that they are looking into, the challenge they want to address, or even the money that they have at the hand, whether it's a small or a bigger budget to do something. Once you select the case, you can get more information about the project, including how is it being implemented, how is it being financed, what are the impacts, how the impacts are being monitored, and so on. We know from the Atlas that urban nature-based solutions can address multiple different sustainability challenges, starting from environmental issues such as climate change, water management, or environmental quality improvements, to social issues such as social cohesion, social justice, improvement of health and well-being. And even we have a lot of evidence for how nature-based solutions can help for economic development, such as tourism support or decent employment. And the Atlas, the cases in the Atlas, our survey of these cases confirms that cities can introduce nature-based solutions to address a wide range of urban sustainability challenges. We see that climate change is one of the important ones in Asia, but the other one is water management. And when we talk about water management challenges, we talk about stormwater and flood management, but also improvements to water quality, how we can handle contaminated water, how we can improve the drinking water qualities and other issues. So when we compare Asian and European cases, we saw that water management, climate change, and social issues are emerging more importantly or more predominantly than in Europe. So many of the cases that are implemented in Asia have this joint focus on how we can handle climate change, but at the same time, how we can improve drinking water, how we can manage flooding, and how we can contribute to improve social and health and well-being of the residents in the cities. We also know from the Atlas, we have a confirmation based on the analysis that urban nature-based solutions can take various forms and can be implemented in various ways. We don't only talk about the creation of of new green areas, but we oftentimes, when we talk about nature-based solutions, we also mean better managing existing urban nature, protecting or even restoring existing natural areas. And oftentimes, we not only talk about physical interventions, but about knowledge creation, improved governance, monitoring. These are all aspects of projects that we can call nature-based solutions. We see, based on the Atlas, we see that an overwhelming percentage of projects are parks and urban forests in Europe and in Asia. It's everywhere, but increasingly we see a lot of projects that are focusing on blue areas or blue infrastructure, such as rivers and lakes, and many projects are trying to use green areas for water management. And similarly, so this is in line with what we see from the challenges in Asia. The existence of projects or the availability of projects that are focusing on blue areas is higher than in Europe. So when we talk about nature-based solutions, oftentimes we are thinking of this kind of solutions when you have a nice green terrace on a roof of an existing building. This is another popular way of doing urban nature is through tree plantations and replacing asphalt with vegetation. This is an example from Canada, where the city focused on urban heat islands with planting trees. But we saw a lot of projects. This is another example from the Philippines, where blue areas or blue infrastructures are created and implemented for managing water. And this is a rain garden project in an existing residential and business area, where they created a lake to capture water and serve as a fire reserve, provide recycled water for irrigation, but also habitat for bamboo birds and used by people for bird watching. And then we have also examples of more technical solutions. This is a wastewater management park in Lombardy, Italy. Next to a river, the project owners constructed wetlands, a set of constructed wetlands to use for pollution management and for flood control. They utilize sand filter beds and retention basins for water treatment, but they also offer educational, recreational, and tourism functions. And the feedback after the implementation from the residents were overwhelmingly positive. So as I already mentioned, but I want to emphasize again that while many projects in our Atlas and in our experience are focusing on the creation of green areas, we also see a lot of projects which are more about how we can manage what it already exists, how we can protect, preserve, and restore existing natural areas. And many projects are also about building capacities, creating knowledge, monitoring biodiversity, impacts of nature-based solutions and green solutions, and so on. So this is, for example, an example where nothing new was created. In the UK, in an existing nature protection area, they decided to improve the functions, the flood management and the stormwater reduction functions of this area, and improve the water quality by introducing different natural techniques to manage the woodland better and to restore habitat in some of the areas and extend the nature park. We also see from the Atlas then that NBS can be implemented by various actors. Local governments, especially in Europe, have an important role in supporting these transformation processes. But we also saw that many of the projects are really successful when they are implemented in a co-government or a hybrid government setup, where government actors are working together with non-governmental actors, universities, research institutions, private actors. For example, this is a project in Bangkok, Thailand, where an old tobacco factory was transformed into a park, which was primarily used for recreational purposes, but also developed in a way that it can help the city with air quality improvements, water management, water quality improvements, flood protection, and so on. This is another example where a dumping ground was transformed into a lake and a protection area, biodiversity protection area. Basically, they let the sewage water to flow into the lake through constructed wetlands. So they were using different type of solutions, such as ponds, oxidation ponds, pedal beds, and different furrows with aquatic plants. And the water slowly entered the lake from basically the dirty water. By the time it arrived to the lake, it was cleaned. And around the lake, they also constructed a park to attract more species and to allow the plants to grow and the animals to come and visit. So basically, from a totally abandoned area, as you can see before the restoration, they created a living lake with various ecosystem services and functions. So we are actually advising or suggesting that community-based approaches to urban planning can be really essential in scaling up the NBS implementations. So actors shouldn't work alone, but by working together, they could really identify and utilize the multiple benefits of NBS. Here you can see that we have identified that many of the projects have these actors working together with the public actors in co-governance arrangements. So to close my presentation, I want to outline that monitoring is essential for understanding and demonstrating the impacts and the benefits of nature-based solutions and help with systematic implementation. We often see from projects that we are studying that monitoring, reporting, and verification is completely lacking. Many projects are being implemented in a sort of vacuum where they start from somewhere, they see the benefits, but understanding and presenting what are the benefits is difficult. But without evidence of impacts and benefits, it's difficult to create a very solid business case for NBS upscaling. So in order to enhance NBS decision-making processes and planning processes, it is crucial that we also advance the monitoring system to understand and measure NBS impacts. So that this reliable and evidence-based data can help not only for a specific project to present the impacts and the benefits, but also for future projects to understand what and how they can do better and in a larger scale. So this is from my side. If you are interested in visiting the Atlas, the address is una.city, and we are always on the lookout for new projects. So if you are interested to submit a project, we also have a function that allows outside visitors to submit a project.
Dora, thank you very much for your presentation. It was very interesting, and we learned a lot from that. So now I think what we can do is we can move on to the question and answers part of our conference. And what I would like to do is open the floor up to the participants, but also open the floor up to the presenters themselves, because I think that we're all working in this field together, and there's quite a lot of interesting work. So presenters themselves may have also some questions for each other. And I will take the benefit of asking the first question. I took some notes for Tobias and Alan and our other speakers, also Claudia. But I would like to ask Dora, because this is kind of how you ended your presentation, is that we learned by Mr. Paul Bardos, if you remember in his presentation, that he was speaking about the issue linked with assessing the impact of nature-based solutions. And I found it very interesting that he has an overall sustainability assessment tool. And that tool was not only measuring quantitative changes in, let's say, quality of ecosystems, but also the social impact and the economic impact of those interventions. So I'm wondering if you have come across that tool before, or if you think such a tool would be interesting for your database and for the work that you do to maybe further investigate that specific tool that was developed by Mr. Bardos. I don't know if it's his tool himself, but he mentioned it as a tool. So I'm also, caught in the same situation with my work, because we have some good, solutions we develop. But how do we measure the sustainability and impact of those through assessment tools? So I think that was also interesting for me. But please go ahead, provide your comments on that question.
Thank you for the question, Brendan. Yeah, so I have not come across before this tool, but indeed there are quite a few tools that can be used for impact assessment. There are several challenges why many of these tools are not being used systematically or at a large scale, including these are always, not always, but most of the time they are very resource efficient, and projects often don't even realize in the beginning of the implementation that how important it is to collect data. So for example, they are lacking baseline data for before implementation, but another challenge is that it's not always easy to collect data. So there are examples, for example, where a project tried to measure whether they were able to reduce air quality, and they had a hard time to prove that air quality issues were reduced or the problem was mitigated by the introduction of that specific nature-based solutions, because there are so many other factors linked and like trade-offs and interlinked issues that makes monitoring challenging. But obviously we looked into potential ways to measure the impacts of the nature-based solutions that are presented in the Atlas. But I think at the end of the day, it's important that monitoring and impact assessment is done at the project level, so the project themselves are aware of the outcomes and the benefits that they create.
Thank you. And just to allow Tobias had a quick response as well to that question. So Tobias, please go ahead, waiting your comments in reaction to that question.
Yeah, we as TAU also have a similar tool for assessing sustainability indicators. So we look at people, planet, prosperity dimensions, and within each of these dimensions, there are some sustainability indicators, and we have a table for that and a sort of scoring table. as well as one of the issues is the carbon footprint, of course, which is a planet dimension. And we have a carbon footprint model to find out about soil works. So, for example, the transport of soil using sheet piles, using chemicals, etc., is all in the model. So we can do the carbon footprinting for soil works as well. So, and it's like Paul Bardos said, it's based on the ISO 18504. So it's the international standards.
And another question, is that tool openly available, or is it a copyrighted material that's used by your company?
The carbon footprint model will be commercially available next year, at the beginning of next year. And the other model we use for our consultancy business, but I can share the global view of how it looks like, and the sustainability indicators. Yeah,
I think that would be excellent. I'd appreciate it, and I can also share it with our colleagues as well after the conference.
Great, thanks.
Any other questions from the audience?
Actually, I would like to ask a question.
Maybe you introduce yourself as well.
Yeah, so I am an employee of Narcos University. My name is Elisher, as you all know me. So my question was that the specialists from TAU presented 4 designs of nature-based solutions. Is there any plans to probably develop this topic and come up with some new prototypes of the nature-based solutions in the future?
So we are and thank you for the question. First of all, we are an engineering firm, so most of our projects come from our clients. We do strive to bring nature-based solutions more into our work field. For example, we've started Soil as a Natural Capital, a working group within the company, which is Tobias is also in that working group. And when clients come to us, we also try to make them aware of the options that are there. Like with the project that we did for the tailing sites in Central Asia, that was a project for the TAU Foundation. So if any of our employees have a very interesting idea, we can go to that foundation to find the funding for that. So for example, we started a project in Suriname where we look at the rehabilitation of abandoned artisanal small-scale mining sites and see how natural options for restoring the soil can lead to a more rapid regeneration of nature in those areas. Yeah, so it both depends on our clients, but we also try to push those solutions ourselves as well.
Thank you for the answer. It was really interesting.
I see that Claudia's hand has been raised. I think she's been patiently waiting. She probably has a lot of questions to ask, I imagine. So feel free. I think we're very much looking forward to answering whatever questions you might have.
Yes, thank you. And yeah, before I come with my questions, I mean, really, congrats to you on a very interesting, informative, and also inspiring seminar that you organized today. So really, congrats to you, Brandon, your colleagues, and all the speakers who presented the interesting projects and experiences. This was really interesting. Thank you so much. And on a side note, I think it would be really interesting to get the presentations and the links to the different tools that were presented here. So thank Thank you very much. And I mean, I think I'm happy to also share this with our community at UNECE. Unfortunately, I didn't have a chance to share the invite in advance, but I'm sure the stream or the link, the recording can also be shared with our community together with the report and possibly the presentations. Maybe they can be made available somewhere so to facilitate the sharing.
I will just to say, I will share all that material with you, and as well as provide you with the YouTube link, and please share that as widely and freely as you would like.
Yeah, excellent. Thank you. Yes, and I have questions to you, Brandon, and also to Dora. Well, to you, Brandon, I mean, you mentioned that in Kazakhstan, basically the environmental code foresees that they have to use 1% of the production costs or operators in Kazakhstan for planting basically vegetation, right? Or there were two things. I think one was a requirement to plant vegetation, and the second was a requirement for sanitary zones or something, right? So I think I just wanted to ask, why am I asking? I ask why this is interesting, because these are very good arguments, of course, to the government to work on such projects. So I was interested in, I mean, do you happen to know if there are other requirements, similar requirements in other Central Asian countries? I think you also went to Kyrgyzstan, as was presented. So is that similar there, or maybe in other Central Asian countries? That would be interesting for me to know. And then, of course, that would be really interesting entry points as well. And I think then, yeah, exactly. I think the second question to you, Brandon, also you answered already partially. Are there future such projects planned? You mentioned there's one in Kazakhstan, but maybe in Kyrgyzstan as well, I don't know, or in other Central Asian countries. That would be interesting. I think Tobias mentioned feasibility studies, that they should be implemented. So I don't know if there are any future plans. That could be interesting. And then I also have questions to Dora on this urban nature atlas, basically. And I mean, I just wanted to know, is there a category also? You mentioned there are different filters. You can search for very specific things. Is there also a category, for example, specifically for tailings or tailings management facilities or something like this? And are the projects that were presented today by the Tao Foundation, by Brandon and so on, are they part of this tool, or is it planned to become part of this tool? Otherwise, maybe this could be an interesting enhancement to introduce nature-based solutions for tailings also into this atlas. Yeah, and I think I'll leave it with that for the moment.
So thank you. See, and that's why you have really people who are interested in the topic, when you can tell that they're really curious to ask questions and to learn about these things in detail. It's a very specific topic that very specific types of people are interested in. So it's good that we have some people that are influential and also willing to share widely the results of our project. So we appreciate your participation, Claudia. To answer your question, in Kazakhstan, there's two separate requirements. One requirement is in the environmental codex, and it says that 1% of the total production costs of a company, of an extraction company, needs to be for research projects. And at that time, like let's say last year before, it was kind of a general requirement. And so all sorts of different things could be considered as research. So like they could have research into digitalization of HR processes, and that could be considered as research. There was lots of it was a very vague general law. And so the companies had a lot of flexibility in implementing that. This year, they are making the law more specific, I was told by the ministry. And so it's going to set out very strict requirements for companies on what qualifies as research. So academic institutions, of course, will be benefiting of this stricter policy, which is being enacted by the government. And the previous project that we had with Altin Almas Company was from this research funding that they have to give for the research grant. The project that we currently have with RG Gold Company is also covered under their research requirements, this 1% of production costs. And at the same time, they have another requirement, which is called the sanitary zone protection requirement. And this says it's a general law in Kazakhstan, which says that 40% of the territory has to be beautified with vegetation. So it could be trees, could be plants, could be grass or shrubs, 40% of the total territory. And typically, these are separate budget lines. The budget line for the sanitary zone protection policy and the budget line for research are independent of each other. And so the company will have to pay for research and then also pay for site beautification. So that's expensive for the company. And the point that I was making with this phytocapture, specifically the phytocapture project, but also for our water waste project, which is currently under contracting, it will be covered under the research grant. But for phytocapture, this specific concept is very good for the company because they can pay for a small percentage of that for research, and then they can use also that research grant to plant vegetation because it's part of the research, rather than coming from the budget for the sanitary zone protection requirements. So it actually saves the company money. And that's another reason why we've been able to cooperate so well with the private sector. Because another question I'm going to have for Dora and for the rest of the team is ask who's usually financing these initiatives. And typically the financing is not coming from companies. It could be potentially coming from municipal government, but very often like international funding sources, like bilateral funds through different embassies, or through like European funds, or other sources like that. It's not usually typically done commercially by companies, or USAID or whatever it might be, World Bank. Okay, so that answers part of your question. The second question is, I've tried to do some research on that, and I'm still going to continue my best to find out, but I don't know the specific legislative requirements for that type of activities in Tajikistan, Uzbekistan, or Kyrgyzstan. But I remember when I was in Tajikistan, I had a conversation with the representative from the ministry who gave one of the opening speeches. If you remember the younger guy who was with us at the dinner. Adash, yes. And he mentioned that they also have sanitary zone protection requirements. But what I would like to know is the specific legislation. And then it's actually quite a better way for me to be able to try to promote and encourage countries in the region to engage in these projects if you can show that there's a financial benefit for the companies. So if that, I need to do my due diligence and to do more research on that specific topic. The second part of your question to me was, sorry.
In Kyrgyzstan also, I think any further projects planned, or if there are further feasibility studies envisaged there.
Yeah, so we're happy that we were able to convince the company in Kazakhstan, but we have a non-disclosure agreement, so we can't mention the company, but to start contracting with us on this natural filter based on different types of biomaterials, which will be installed in the waterway to reduce heavy metal pollution. So we're in the process of contracting for that. So that design that we presented and that we presented today has actually been of interest to the company that we did this prototype design for, and we're going to be beginning the commercial design for that in the spring. Because as Tobias mentioned, we still need to have information on water flux during the perennial melt of the the snow. So we have to get more measurements and do more like due diligence there in terms of the technical issues linked with that specific waterway where we identified the heavy metal pollution. And then after the commercial design is done, completed, which will be probably in July or August, we hope, then we would actually launch the filter, install it on site before the winter time. So it would be like September, October, November, in that time frame. And then in terms of Kyrgyzstan, we presented it to the shareholders, our proposals of prototype designs. And we're in discussion with them currently. That's open because it's Aktu's mine and we don't have a non-disclosure agreement with them. So I think that that's something that we can publicize. But no specific agreement has been made to proceed with any of the prototype designs currently. But the idea also is that all of these designs that were developed for both of those sites, active site and abandoned mine tailing site, can be adapted for other abandoned sites or other active mine tailing sites, not only in Central Asia, but essentially anywhere. So I think that this is something that is applicable, and why we created the summary report was to make sure that this was something that could be widely disseminated and picked up by other interested parties, whoever they may be. So I hope that answers your question. And I can share more information with that for you as well. And like I said, we plan on implementing it in September, October, November next year. The whole project is a go over the course of 2024 when the contract is finalized. So I'm happy to share that also within your network and to present this as another practice for the reduction of heavy metal waste in waterways and its potential impact also for transboundary waterways. So we can still continue and cooperate on those issues in the upcoming year. Dora, please, if you'd like to answer her question.
Yeah, thank you for the questions. They are very relevant. So I did mention about governance, but I didn't mention about financing. And yes, indeed, when we look at who is financing this project, we often see that the majority of the money is coming from local governments in Europe. And for example, when we look at specifically Asia, it's more about national and international funding. And I just made a quick search in the Atlas. As I mentioned, there are several filtering functions. Less than 10% of the projects are developed and initiated by private companies. And around 5% are financed by their own resources. This means that, and oftentimes when we see these projects, they are very small scale. So a train company would do a community garden at one of their train stations and so on. So I think this kind of large projects where what you have presented today, so I was really impressed, but it's really missing from the Atlas, but I think in global practices in general. So I think as Claudia asked, there is definitely a space for more industrial projects. For the Atlas, we are open for opportunities, and we are always looking for ways to enhance the Atlas. This is something I think it's really gaining attention in the last couple of years. So I hope that in the future we will have more similar cases. To answer specifically Claudia's question, we do have a few cases in the Atlas that happened or were implemented on mining sites. Around 10-15 cases. I just also searched that. We don't have a specific filter for this. The nature-based solutions that are presented in the Atlas are broader types, such as parks, community gardens, green area-based water management solutions. But we also introduced the specific search function where you can just type what you are looking for. So if you are specifically looking for mine site projects, then you can just find those by this. And I think I also have a question, if that's okay.
Yeah, just one more comment because she asked specifically. So yes, the one that we did on Aksu mine, which
Yeah.
I presented, Claudia, you know about that case, presented it. So that is in the Urban Atlas. Dora added that last year, and it's in the Atlas now. Hopefully the water one can go in at some point too.
And just to say that I just checked it, and that's the only project about tailing in the Atlas among the 1,200 cases. So the project is that innovative. So, yeah. So the question I have to Tobias and Ellen is about the projects that you are planning, and I may have missed it, and apologies if I did, but I was wondering about the social impact. So you mostly talked about the environmental impacts, and obviously these environmental impacts have social impacts, but I'm just wondering whether you looked at who are the impacted people and how these solutions will improve their life, and whether you considered involving them in the planning process via a stakeholder consultation.
Yeah, of course, we only looked at the health impact of people, and we didn't really look at the social part. So we looked, of course, at the health impact of the workers on site and of the people living near the site. But it's a really good one you mentioned here, because we should also look at the social impact of these projects. Maybe we can use we will make use of the site staff for implementing these nature-based solutions. So that might be a social aspect. So they will be part of the solution, but we didn't look at the inhabitants near the site. So that could be that could be an aspect as well. Also on base of education, for example. So I think that's really a good one. But yeah.
And thank you so much.
Yeah, absolutely. Sorry if I may comment on that. I had a similar question actually. So it's really good that you raised this, Dora, because I mean, what we anticipate is that the number of tailings management facilities will increase significantly given the increase of the global demand for minerals and metals. That also means that the risks to the people and the environment will increase. And that also means, I mean, looking specifically at people, that it will be even more important to involve them and get their support also for, I mean, the operation or extension of projects in particular. And I mean, nature-based solutions can be a means also to increase trust building, I guess, between operators, private sector, and also the local communities. So absolutely.
Yeah, one additional is sort of like this, maybe like a brainstorm. Apologies for this, but I think it's relevant. Is that keep in mind a lot of these countries are signatories to the Aarhus Convention, which is access to justice, access to information, access to decision-making in environmental issues. So the point is that there's Kazakhstan is also a signatory. So there's a legal obligation for them to enact this convention. And so if you want to develop social indicators for, let's say, these type of NBS projects that are linked with the industrial sector, then you can use the requirements under the Aarhus Convention to develop a set of indicators that could then be used to analyze the social performance against those indicators.
Yeah, and I guess there may also already be work existing. There are these Aarhus centers in some countries. I don't know. There's a lot of information already available, and I think in Central Asia, it's also OCE working a lot on community engagement in this regard. So that may also be an interesting partner in such a project.
And just to add that I completely agree with what Claudia said, that the social acceptance and local ownership are really crucial for the long-term success of nature-based solution projects. So, and oftentimes we don't fully understand the whole spectrum of benefits that these projects can deliver unless we talk to the people who live around. And so I think it's good to reach out and understand their views and their feelings about the project prior to it, and then also after implementation.
Yeah,
And just to promote our convention, we also have an article 9 of the convention, which is on public information participation and basically access to justice. One of the areas in the convention that countries struggle with. So definitely there is potential for all parties to improve their implementation of these provisions under the convention.
And to go kind of narrow again, and apologies for that, I have a question for Tobias also about this root sleeve, because I remember learning about that previously, your Dow Benelux project. Is that, how did you said, oh, it was a very effective project, and then based on that, they plan on doing it again at another site. So I'm wondering, in that case, because we were talking about measuring effectiveness, right? So what type of indicators did you use for effectiveness for that specific project? Were they soil samples, water samples, so like before and after? Maybe you could just elaborate that on a little bit more. Thank you.
Are you taking it or I?
Or Ellen, whoever knows
Okay.
more about the answer to that. I ask both of you.
The first project really focused on the monitoring of the groundwater, because that's where the pollution was, and to see if the contamination spread to other areas, and to see how the concentrations in the groundwater were affected by this phytoremediation system. Now that second project that we are doing, the trees were planted last March, and there we use a few extra parameters. We're also looking at the trees, so we're monitoring the concentrations in the groundwater as well, but also see how much pollutants actually end up in the trees, and how these trees affect the environment. Because in the winter or in the fall, of course, they lose their leaves, and we don't want any contamination from that to spread into the environment. So we're monitoring the concentrations in the leaves before and after they fall to see if any measures needs to be taken there. The overall health of the trees. Yeah, and we also installed a flux meter in the straws to see how much water is actually being taken up by the trees and what are the concentrations of the contaminants in that water, to get a more precise estimate of the pollution that is being removed.
Okay, thank you. So primarily ecological indicators then.
Yeah.
Okay, thanks. Yeah, that's very clear. Appreciate that. And now I guess maybe one more question, and then from myself, and if there's any other questions, we'll have one additional question, and then we'll wrap up. So one additional question for Claudia is related to the convention specifically. And you mentioned that there's 42 signatories to the convention out of the 56 countries, and that in Central Asia, Kazakhstan is the only signatory. My question for you is, what is the roadmap for I mean, you mentioned these activities, right? That you have these different events, which are great. And I look forward to participating whenever I can, if an invitation comes my way. So it's been very helpful, as you know. So now we have very good relationship with the Ministry of Industrial Accidents and mine tailing safety for Kazakhstan. So we are very happy to have that relationship that was facilitated through our cooperation at some of these conferences. So thank you for that. But my question for you is, how do you envision, how does the UNECE envision your involvement in Central Asia, specifically linked with the convention, and engaging more countries in the region in that? Are you seeing some potential for new signatories in the future, or is this something that is still kind of undisclosed or undecided at the moment? Maybe you could just give us a little more about the convention in Central Asia. Thank you.
Yes, thank you for the question. Very good. So just on the terminology, so we talk about parties to the convention. So we have 42 parties to the convention. There is, I'm highlighting this because we actually also have the US and Canada as signatories to the convention. However, they never ratified in the end the convention. And as you may know, or some of you may know, the United Nations Economic Commission for Europe has also the US and Canada as part of its region historically. And in some conventions, the US and Canada are also active, however, not in ours, as I mentioned. So among the 42 parties, indeed, there is only one from Central Asia, and that's Kazakhstan. And Kazakhstan has been very active in the past. Of course, we are always working with other countries on accession, and especially with countries with economies in transition. Under the convention, we have an assistance and cooperation program that supports countries with economies in transition in strengthening industrial safety, tailing safety, and also in acceding to the convention. So Tajikistan is now in the process of really exploring, consulting with all the different national authorities on the implications of accession to the convention. And we are hopeful that this well, we're hopeful and supporting them in this process, and hopeful that they possibly become a party at the next meeting of the Conference of the Parties. But of course, I mean, we need to follow the proper steps and process. And what has been instrumental in this regard was also the interinstitutional working group on tailing safety and the prevention of accidental water pollution, because among the action items in the work plan, there is one that actually suggests exploring accession to the convention. So if then Tajikistan at its third meeting of the interinstitutional working group next year will review the action items, I'm hopeful that they have good news to share, and then it means that also these interinstitutional working groups are vehicles to strengthen implementation, tailing safety in Central Asia. And we are also supporting currently Uzbekistan in creating such an interinstitutional working group. We know that in the national concept of Uzbekistan, there's also the accession to the convention included until 2030. So of course, that's another country we hope to support, or we are already currently with projects, but also in the future. And yeah, of course, the assistance activities depend also on funding. I mean, we're always there to support countries, but the reality is also that we can be more active and engaged if there is specific funding for projects. And so you have seen the needs that are presented from the sub-regional workshop. Climate change is very high on the agenda in Central Asia, climate change specifically with regard to tailings management facilities. So assessing the impacts, understanding the risks, and taking measures to adapt and to prevent accidents. So that will be, I guess, also high on our agenda, because it's high on the country's agenda. And by doing all of this, of course, the roadmap, the 2030 roadmap for tailing safety will be implemented, but the countries are the main implementers, I would say, of that roadmap, right? We are supporting them, but there needs to happen a lot nationally, regionally, locally, right? So we are here to support, but the main drivers are the countries themselves.
Thank you very much for the answer. Is there any last pressing question before I wrap up the conference? Speak now or forever hold your peace. I'm joking. You can always send an email to me with your questions after the event. It's not your last time. So, okay. In any case, I would like to wrap up the event. I'm really happy to see how we can take, and this is a really core example of what you need to do. you have local level, local level, national level, regional level, international level, working together with academia, with international organizations, with companies, and with citizens to try to improve and enhance the quality of sustainability around the world. And so I'm very happy that we had this conference today. As I said, everything is recorded and streamed on YouTube. So there will be a recording of this, which will be shared widely as well. Last time we had this meeting, it was a conference last year. It was a similar situation that at the end, there was about maybe 10, 15 people left. I appreciate everybody who's here now. Thank you for staying till the end. But we had about 200 or 300 people which viewed it after the conclusion of the conference. So I'm sure that we will have a lot of people viewing this later because it's a very content-heavy conference with a lot of very good, useful information. And people who are interested in this particular topic and this particular field, I think, can learn a lot from the presentations we had and from the speakers that we had during the event. So once again, I would thank you all for participating. And I would thank all the speakers as well for taking time out of their busy schedule. We have a lot of international people here, which have a lot to do. So we appreciate you spending time to participate in our conference and providing very good presentations. And we look forward to our future cooperation. I know with TAU, we will be cooperating, hopefully, on our future contract and other work together. And with the UNECE, with our participation in the convention, we're happy to support it as much as possible, our institute and also our university. And I want to thank you all for coming and have a wonderful weekend ahead and take care.
Thanks, Brandon, for the invitation.
Thank you for
Thank
coming.
you.
Appreciate it.
Thank you.
Have a great time.
Bye-bye. Thanks
Take
a
care.
lot.
Bye.
Thank you all.
Thank you.